Alright, section 4.2, congruence in triangles. We're going to look at the essential question, what are the characteristics of congruent figures? Specifically triangles, but we'll see an example in here of a trapezoid, congruent trapezoid. So which parts are not congruent if triangle PQR is congruent to triangle XYZ? So the specific order PQR and XYZ is the key crucial part to this question. So segment PQ, you can see P is followed by Q, is congruent to XY. Those are in the exact same location and the exact same order, so choice A looks good. Angle R, which R is in the last position in triangle PQR, is congruent to angle Z, which is also in the last position of triangle XYZ. That looks good. Angle Y, okay, angle Y, which is in the middle position of XYZ, congruent to angle P, which is in the first position, definitely not correct. So C is the part that's not congruent in these triangles. Okay, given triangle LMN congruent to triangle PQR, and the angle measurements of those given in the diagram, what's the measure of angle R? Well, let's figure out what we know about triangle QPR or PQR. Same thing, because we're looking for the measurement of angle R. So we know that angles L, here's angle L, congruent to angle P. They're in the same position in the congruence statement of the two triangles. So L and P must be congruent. That means P is 105 degrees, just like angle L. So these are congruent angles. Great, we got angle P. We've got angle Q, it's 45 degrees. So the measurement of angle R is whatever is needed to add all three angles up to 180 degrees. So the measurement of angle R, R is 180 minus the measurement of angle P, which is 105, minus the measurement of angle Q, which is 45, and that gets us final answer. Okay, here are the trapezoids. Use properties of congruent figures, and we're given side lengths. So let's label the side lengths. AB here is 9, DC here is 6. Solve for x and y, and the figure ABCD, congruent to EF, GH, and that tells us specifically the order. So x and y are in statements. X is in the statement in the diagram showing the length of segment EF. Well, segment EF, you can see it here, corresponds to segment AB based on the congruent statement. So what's AB? AB here is 9. So we know that 4x minus 3 equals 9. 4x is 12, so x is 3. Alright, solve for x, got it. Now y is shown in the diagram to be an angle, part of an angle expression, and that angle is angle H. So what's H's location? H is in the very last position of the congruent statement, so is D. Well, here's D, 96 degrees. So 5y minus 14 is equal to 96. 5y is 110. Y is 22. This next example is going to use the third angles theorem. Based on the diagram, you can see that angle N is congruent to angle R. You've got the double curves there showing congruence. Angle L and angle S are congruent. You've got the single arcs there, the single curves, showing those angles are congruent. Then from the third angles theorem, you know the remaining two angles, M and T, must be congruent. If two of the angles are congruent, then the third angles must be. From the triangle sum theorem, knowing the 55-degree angle N and the 65-degree angle L, we know that angle M must end up being 60 degrees. M is, the measurement of angle M is the same as angle T. Now we're going to solve the expression 2x plus 30 to be equal to the 60 degrees we solved angle M to be. So subtract 30, divide by 2. We've solved for x, it's 15. Here's a proof. Decide whether the angles are congruent and justify your reasoning. Now, the diagram has given us a bunch of information, so let's write those out based on what's given in the diagram. So here's what it looks like. Segment RP with the one slash through it is congruent to segment MN with one slash. Segment PQ is congruent to segment NQ, the double slash. And lastly, segment QR is congruent to segment QM with the triple slash. Those are all given. Also given is the measurements of angle P and N, and they're the same. So angle P is congruent to angle N, and that's by the definition of congruent angles. Their measurements are the same. So we have three congruent side lengths. We have a congruent angle. Now, how can we say that angle PQR is congruent to angle NQM? Well, if you actually look at their positions, here's PQR and here's NQM. What kind of angle pair are those? Well, they're vertical angles, so by the vertical angle theorem, those are congruent angles. So now we have three congruent sides. We've got two congruent angles. Two congruent angles means by the third angles theorem that the third angles are congruent. R and M are congruent. Well, three congruent sides, three congruent angles tells us that triangle, get the triangle in there, triangle PQR congruent to triangle NQM. And that's the definition, congruent triangles. Okay, one last example here. Let's try to prove triangle AEB is congruent to angle DEC. And we're going to take what's given in the diagram, and that is segment AB is congruent to segment CD. You've got the arrows showing parallel. Segment AB is congruent to segment DC. You got the one slash through it. Now what we don't know from the diagram is that E is the midpoint of the two diagonals, BC and AD. So here's what we need to prove, as stated above, that the triangles AEB and DEC are congruent, and our plan is to use the fact that the sort of center angles, AEB and CED, DEC, are vertical. So those angles are congruent. BC and AD intersect parallel segments, and that's going to help us taking a look at other angles being congruent. So let's back up here and we'll say, let's start our proof. AB is parallel to DC. Segment AB is congruent to segment DC. And E is the midpoint of BC and AD. All of that's given. So we already have one set of congruent sides, and that's segment AB and segment DC. Well, this midpoint, E being the midpoint, that tells us that AE is congruent to D, and it tells us that CE is congruent to BE, and that's by the definition of a midpoint. Midpoint, try that again. Midpoint. So that gets us actually 3 congruent sides now. AB is congruent to DC, AE is congruent to DE, CE is congruent to BE. So we have all 3 sides are congruent. Now, as was stated earlier, we can say that angle AEB is congruent to angle DEC, and that's by the vertical angle theorem. Those are vertical angles. And we can say that angle BAE is congruent to angle angle CDE. So let's see those. BAE is this angle, BAE, and then CDE is this angle. Why are those congruent? Well, if you look at this transversal of 2 parallel lines, what's the relationship between the 2 angles that are determined? They are the alternate interior angles theorem. So those are congruent. So now we have 2 sets of congruent angles, and the last thing we need is angle ABE congruent to angle DCE, and that's the same thing, alternate interior angles, only we're looking at, instead of this transversal, which I'll erase, we're looking at this transversal and these 2 alternate interior angles. Well, that tells us that triangle AEB congruent to triangle DEC by the definition of congruent triangles.